Hi, in this session we will consider the isometric projection of a pentagonal prism of base edge 30 mm and height 60 mm. And its base edge is, one of its base edge is parallel to the vertical plane. So first of all you have to draw the simple plan and its corresponding elevation. This edge must be parallel to the XY line because it is mentioned in your question paper. After that you have to mark the coordinates, that is A, B, C, D and E, which marks the base, F, G, H, I and J, which marks the top face. And that is the symbol, plan and elevation. First you have to draw the symbol, plan and elevation. After drawing the symbol, plan and elevation, you have to place the pentagon in a square. Here you are placing the pentagon inside a square. And the coordinates of the, here actually you are placing the pentagonal prism in a square prism, and the base edge, base corner dimensions, the corner points are point 1, 2, 3 and 4, and the top coordinates are 5, 6, 7 and 8. And draw the corresponding positions of 1 dash, 2 dash, 3 dash and 4 dash, 5 dash, 6 dash, 7 dash and 8 dash in the elevation. So first draw the pentagon, draw the elevation, then enclose the pentagon in a square prism and its points are 1, 2, 3 etc. After that you are, first of all you are considering the isometric projection of this enclosing square prism. And for drawing isometric projection you have to take isometric scale. Here first of all let us mark the position of point 2, and while measuring this dimension 1, 2 I got 50 mm, and I have to take the isometric scale of 50, and for getting the value 50 multiplied by 0.816, that is equal to 40.8. So the isometric equivalent of this dimension is 50 multiplied by 0.816, that is equal to 40.8. This dimension is 40.8, and we have to find the next dimension. This dimension, this slightly different. This is not a square but it is a rectangle. Actually it is a rectangle. It appears to be square but there is slight difference. This dimension is smaller than this dimension. This is 46, this is 50. So for getting the isometric equivalent of this side you have to multiply 46 with 0.816, so that you will get for multiplying 46 multiplied by 0.816, that will give around 37.5. So this the isometric equivalent of this dimension is 40.8. It is approximately 41 mm. Can round off, and the isometric equivalent of this side is 37.5. After that you have to mark a point here, and that is the position of point 1. This is point 1, and that corresponding position is marked here. And from point 1 you have to draw a 30-degree line in this direction. This angle is 30 degree, and another 30-degree line in this direction. This angle is also 30 degree. So two 30-degree lines starting from point 1 in both directions. After that, you have to take this isometric scale. For marking point 2, you have to take 41 mm in your compass. Take 41 mm in your compass. This is 41 mm. Take 41 mm in your compass, and with 1 R center intersecting here. And that is the position of point 2. Then for getting point 4. Point 4 is this much distance away from point 1. The isometric equivalent of that distance is 37.5. Take that distance in your compass. 37.5 in your compass. And with 1 R center intersect, so that you will get a point somewhere here, and that is point 4. So we got point 2 and point 4. We have to locate point 3. For that, you have to place your 30 degrees set square like this. And I am drawing 30-degree lines from point 2 and from point 4. From point 2 and from point 4. So that you will get a parallelogram like this. This dimension will be equal to this dimension, the isometric equivalent of this dimension, that is equal to 37.5, that is this one, and this dimension and this dimensions should be equal to 41 mm. So that you will get an intersection at this vertical projector, and that is point 3. After this, so this 1, 2, 3, 4 marks the base of the enclosing prism, and after that you have to project upwards. And after that you have to mark the top points, and for this prism the total height is 60 mm. So take 60 multiplied by what, find the value of the corresponding isometric distance. 60 multiplied by 0.816, that will give 49 mm. Take 49 mm in your compass. Taking 49 mm in your compass. And with 1 R center intersecting here, with 2 R center intersecting here, 3 as center, another point here, 4 as center intersecting here. This distance is 41 mm. This is 41 mm. This is 41 mm. Not 1, 2 is 41 mm. Distance must be 41 mm. This distance must be 37.5. It is 30. Take 37.5. Take 37.5 and have to check this. This is 37.5. This is 37.5. This is also 37.5. This is 41. This is also 41. And after that you are marking 49 mm as height. And you will get 4 points. And that points are point 5, 6, 7 and 8. After that join that by means of thin lines. It must be thin lines. It's not your final projection. So, this figure denotes the isometric projection of the enclosing cage, not the isometric projection of this pentagon. Now, how will you locate the pentagon inside this cage? For that, you consider point B. Point B is the midpoint of edge 1, 2. So, this dimension is 41 mm. So, midpoint of 41 is 20.5. Take 20.5 in your compass and mark that distance. So, this is the position of point B, because we know that point B is located on edge 1, 2 and it is the midpoint. You can mark point B here. Similarly, you can mark point G. Point G is the midpoint of the top edge 5, 6. So, take keeping the same distance in your compass and intersecting here and marking the point here, that is point capital G. Then what about point A? Point A is located this much distance away from point 1 towards point 4. Take that distance. This is 12 mm. So 12 multiplied by 0.816. 12 multiplied by 0.816 will give around 10 mm. This is 12 mm. 12 multiplied by 0.816 will give 10 mm, approximately 10 mm, this distance. And this is 1/4. And in that side, you have to mark 10 mm. Take 10 mm in your compass. Taking this distance. And I am marking it here. And that is the position of point capital A. And capital F is directly above point A. Point A is located on 1/4 and capital F is located on 5, 8. You can mark the same distance here also. And that is the position of point capital A. So, not capital A. Capital A is located on the base, and here we have, what is that distance? This capital F, not point capital A. Capital F. So we got A, B, G and F. 2 points in the base. Now let us consider the other points in the base. Point C. Point C is located at the same distance away from point 2 towards point 3. If you measure this distance, you will get 12 mm. That is equal to this dimension. So, keeping 10 mm in your compass, what is 10? 10 is the isometric equivalent of 12. Mark here and here, so that you will get the position of C and H. Now, we have 2 points, that is point E and D in the base, and these points are located, how much distance? This is 10 mm away from point 4 towards point 3. 10 multiplied by 0.816 will give around 8 mm. So take 8 mm in your compass, and with 4 as center, marking a point here, and this distance and this distance will be the same. So keeping the same distance in your compass, you can mark another point in the opposite direction. Similarly, from point 8 towards point 7, and from 7 towards point 8, so that you will get points D and E. These points are located in the base, and these points, that is point, this is point I, and this is point capital J. After that, you can connect. First of all, let us connect the boundary. So that is the boundary. And here in this case, the top face is fully visible. So we can connect the top points. Fj and Fg and Gh. After that, we have to connect the lateral edge AF, BG and that completes the visible faces, visible edges. Now we have to consider the hidden edges. ED is hidden. DC is hidden. Join that. Then ID, the lateral edge ID is hidden. That must be dotted. And that completes our isometric projection of the pentagonal prism. You have to place the object in a square cage or a rectangular cage, and you are marking the corresponding positions of the points, that is A, B, C, D, etc. inside the that reference cage, and drawing the lines. And that completes our third problem. Thank you.